A system is a set of two or more equations with variables that are the same. And to find the solution of a system, we want to find all the ordered pairs that work in all of the equations. We're going to be focused on systems that only have two equations, but you can have many more equations in a system. We will have three methods for solving. They will be graphing, which we'll look at in this video, followed by substitution, and then the third method we'll be exploring is addition, or sometimes called elimination. To solve by graphing, the first thing you have to do is graph both equations. We're going to focus on graphing using slope-intercept form. Once we've graphed them, then we need to find the point of intersection if there is one. If there is one, the solution will be listed as an ordered pair with an x and a y that works in both equations. This is called a consistent system with one solution. Next, we're going to consider if there's no point of intersection. In this case, there's two scenarios that could occur. We could have the lines being parallel, where they never cross, and in that case, there is no solution, and it's considered an inconsistent system. However, there's also a scenario where the lines are actually the same line, and in that case, there are infinitely many solutions, and this is called a consistent system. Finally, to ensure that your work was done accurately, it's important to check the ordered pair that you have calculated to be the intersection to make sure it works in both equations. We're going to look at this system and solve it by graphing. Notice here that both lines are in slope-intercept form, which is y equals mx plus b. And to graph in slope-intercept form, we graph the y-intercept first, which is the b value, and then we rise and run based upon slope. I'm going to graph the first one here in pink. And so first I will graph the y-intercept of 4. So I'm going to go to 0, 4. And then my slope in this case is -1/1. So I will come down 1 and over 1, giving me a line like this. I'm going to graph my second graph in green. My y-intercept here is a +1. And then my slope in this case is a +2/1. So I will rise 2 and run 1, giving me a graph that looks like this. We can see here our point of intersection is going to be 1, 3. And as confirmation of that, we can go back to both equations. In our pink equation, we can plug in 3 for y, plug in 1 for x, and we see that 3 does indeed equal -1 + 4. For our green equation, we can also plug in 3 for y and 1 for x, and we see that 2 times 1 + 1 is indeed 3. They both work.